Okay, example 1, you've got two masses A and B with masses 0.4 and 0.8 kilograms respectively, connected by a light inextensible string. Particle A lies on a rough horizontal table, so this bit here is rough, 4.5 meters from a small smooth fixed pulley which is attached to the end of the table. If the pulley wasn't smooth, this would affect the tension either side. Okay, but it is smooth. String passed through the pulley and B hangs freely with the string taut 0.5 meters above the ground. So this is 0.5 here. I'll put that on for you now actually. We don't need that yet, but you'll need that later in the question. The coefficient of friction is 0.2. The system is released from rest. Find A, the acceleration, B, the tension, C, the velocity when B hits the ground. Okay, remember this is B, this is A. So A has got a mass of 0.4, B a mass of 0.8. So if I'm going to put all my forces on here now, remember, we'll put the weights on first. Sorry, move down slightly. So the weight of this one is 0.8 G, this one is 0.4 G. Okay, then we're going to have tension moving away from the object, so tension and tension. We're going to have a reaction here because this is sat on a surface. And then because this is rough, now this is going to move, and you can tell you in the question because when it hits the ground, so it's going to move this way with an acceleration. So this is going to go this way. So if it's going this way, you must have friction act in the opposite direction to movement, so friction is going to go there. Okay? So for part A, I asked you to find the acceleration. So to find the acceleration, all we've got to do is do F equals ma for this object, F equals ma for that object, simultaneously solve them. But before we do that, we want to try and find friction. So we should remember, hopefully, that the friction, because it's moving, we can use equals mu times r. Now to find r, we're just looking at this object, okay, because this is the one that's being dealt with by friction. So if you look at object A, if we do forces up equal forces down to find r. Just for object A. So for object A, r equals 0.4 G. Forces up equal forces down, which is 3.92 newtons. I know from the question that the coefficient mu is 0.2, so I can put 0.2 in this into the friction formula. So we get friction is 0.2 times r, so friction is 0.784 newtons. Okay. Once you've got that, then it's very similar to what we did in Unit 2. Hopefully you can remember this. We do for object A, then for object B, and then we solve them simultaneously. So for object A, I'm going to do F equals ma. And if you go back up to the diagram, so it's a bit moving about, it's moving this way. So force in direction movement is T. Take away force holding back is friction, because it's going this way. So we have T, take away friction, is the mass of object A, which is 0.4 times A. Now I know what friction is, I just worked that out. That was 0.784 equals 0.4A. That's our first equation. Okay. Then I could do for object B. So for object B, if we look at object B, we're going to do F equals ma again. And which way is object B moving? Well, object B is moving down. So force in direction of motion is 0.8 G. Take away T. Okay, you just look at object B, just look at this little bit here. So we have 0.8 G, take away T, because going down, equals 0.8 times A. You can work this out if you want. That comes to 7.84. Take away T is 0.8A. Equation 2. And remember with these now is always add, because you've got a positive T and a negative T. Different sign, add. So 1, add 2. So if I add the equations up, the T will disappear. Add this, minus 0.784, add 7.84, comes to 7.056. Add the A's, 0.4 and 0.8 is 1.2A. Divide by 1.2. We're out of room. So you end up with A being 5.88 meters per second to the minus 2. Okay, that's part A. think I may need to record part B and C on a separate video, okay, because I've run out of time if you go over 5 minutes.